Okay, I don't think I'm allowed to share.
Oh, you're not?
Wait, hold on. Oh, yes, I am. There we go. Okay. All right. Oh, it's at the end. Okay. First, I just want to thank Glenn for inviting me. I think this is a great series. And you had to invite 4 times the number of speakers that you would have had to if you'd had individual speakers. And I want to thank Snow also for doing so much work organizing this. You know, you never know how much work is involved unless something goes wrong, and then you know, but since things aren't going wrong, you don't know. Let me just, can I make that a little bit bigger? Oops, not like that. Okay. So I am going to talk kind of fast because I'm trying to provide some context in 10 minutes. You know, although I'm one of the people representing philosophers, I know that not all the philosophers here will necessarily agree with me. But that's what you get in 10 minutes. So. Well, they wouldn't agree anyway. Okay, this is sort of just, this is going to be basic for some people, some of what I have to say. So what's an interpretation of probability? And an interpretation of probability specifies what in the world probabilities are in some context, what things satisfy axioms of probability. And so we have our subjective or epistemic or Bayesian interpretations where the probabilities are degrees of belief or something about behavioral patterns, epistemic relationships. Objective probability interpretations, or sometimes they're called chances, could be frequencies or probabilistic dispositions, which philosophers call propensities based on, inspired by Popper. I think also there are causal structures that generate outcomes with certain frequencies that could be called probabilities. They're best system probabilities, which I'm not going to talk about. I have great respect for that tradition, but it's not sort of part of my approach. But I just want to point out, not everything in the world that satisfies axioms of probability count as interpreting probability, as providing an interpretation. So, you know, if you assume that a tabletop has a normalized Lebesgue measure, there's something objective about that, but that doesn't count. And exactly why it doesn't count is a good question, but that's not an interpretation of probability, even though it is something that satisfies the axioms. I'll say a little bit more about game theoretic probability later. I'm not sure exactly where it belongs in this taxonomy. Okay, I want to distinguish between single case probability interpretations and long run interpretations. A single case interpretation is one that assigns probabilities to individual trials. So an individual, like tossing a die or performing an experiment, if you want to say that there's a probability in that particular setup, as it's realized in an actual situation, you're using a single case interpretation. And you know, if you're a Bayesian, this is easy. But for objective probability, there's a question about whether that's the right way to think about things. Long run probabilities and interpretations only assign probabilities to events when there are many trials. So you don't get objective probabilities on individual trials, at least not easily. There might be ways to do it, but you have to work at that. You can still get subjective probabilities on individual trials. That's not hard. But the important thing to notice, oh, and let me just say, I've got a lot of words on my slides. You don't have to read them. I'm going to talk through them. But if you want to go back and look at something, most of the words are there, and there's a URL at the bottom of each slide that tells you where to get this PDF. So one of the things I think that's really important in this context is that if you're assuming there's a single case interpretation that applies to individual trials, then if you have many trials, you can derive probabilities of long run frequencies. That's what long run laws of large numbers do. But that doesn't mean you've got a long run interpretation. It's still a single case interpretation. It's only a long run interpretation if it refuses to attribute probabilities to single trials. So frequency interpretation. So I want to be very clear. I don't think frequentist statistics needs frequency interpretations. I'm not even sure they ever used them, but even though people said they did. I can talk about that later if there's time. So we've got an actual finite frequency interpretation. Probability just is actual frequency in some population and nothing more. That's all it is. Hypothetical frequency, that's where you say, well, the frequencies would be in some counterfactual situation equal to some frequency or near some frequency. I think there's some, von Mises seems like a hypothetical frequency person, but I'm not sure that he actually is trading in counterfactuals. This is a matter of interpretation. But the hypothetical here, it means something like imagined or counterfactual, or could be, or something more subtle. I don't think it means what Neyman meant by hypothetical in the article that Glenn suggested. That seems to mean hypothesized or implied by a model. It's a very different concept. So among the hypothetical frequency interpretations, we have long run or infinite limiting frequency interpretations, and finite, but maybe long run counterfactual frequency interpretations. Long run propensity is very closely related to those, but it adds the claim that there's a disposition, and then you have to talk about what a disposition is that produces frequencies near certain values. These are all long run interpretations. That is, in themselves, they say nothing about single cases. The questions. Question one, the repeated sampling principle can be taken as saying that the meaning of a probability measure lies in the assumption that the salient probabilities and expected values given by the measure will be replicated by frequencies and averages in hypothetical repetitions. Is this a frequentist interpretation? So if what it's saying is that, if what this statement is saying, if the repeated sampling principle is saying that probabilities are long-run frequencies or are numbers close to long-run frequencies, then yeah, that's a long-run, that's a frequency interpretation of probability on my view. And Cox and Hinckley seem to say this: measures of uncertainty are to be interpreted as hypothetical frequencies, and long-run interpretations are to be interpreted. In the actual question, I think it's a little bit ambiguous because it's consistent with the idea that we're deriving the claim that the frequencies and averages will be near R from single case chances. And if we're doing that, then that's not a frequency interpretation. It's some other kind of single case interpretation. So I would say no. The next question is about Cournot's principle. So I'll talk about that. It's supposed to be vague. I think that's pretty clear from what Glenn's written, because he's trying to collect together lots of different closely related views. In the handout, he says Cournot's principle would justify inferences by statements to which the model gives high probability. In his working paper, he says Cournot's principle equates high probability with practical certainty, or sometimes the phrase moral certainty comes up in the paper. The way I understand this, what's being said, is that it's saying that if A has high probability, believe that A, or if A has high probability, act as if A were true. So as stated, if it has unrestricted scope, then it also applies to single case probabilities. So, when I throw a 100-sided die once, so the probability is it's numbered from 1 to 100. There's a very high probability that the outcome is going to be between 2 and 100. So I should believe that. And I'm not going to worry about lottery paradoxes or anything right now. But that's what, but the point is, it's applying, Cournot's principle then is applying to a single case. We can also have a restricted version, which might actually be better. I think it's not in the end, but it looks closer to being able to give Glenn's question a yes. So the long run Cournot's principle restricts its application only to cases where you're talking about frequencies in large numbers of trials. So when there's a high probability that the frequency of outcomes in a large number of trials would be near R, you should believe or act as if the frequency will be near R, or maybe will be equal R. That would be the long run Cournot's principle. So question 2. Similarly, Cournot's principle says the meaning of a probability measure lies in the assumption that salient events with probability close to 1 will happen. Is this a frequentist interpretation of probability? So if this is the unrestricted Cournot's principle that applies to single cases, I'm going to say no. It just does. It's not a frequency interpretation because it's telling you things, because frequency interpretations are long run interpretations, and this is making a claim about single case chances. Or it's based on a claim about single case chances. But if we restrict Cournot's principle of long run frequencies, so we're using the long run Cournot's principles. So the meaning of a probability measure lies in the assumption that the long run frequencies will have probability close to 1, that have probability close to 1 will happen. So then I want to know, well, what are those probabilities of the long run frequencies? If there are also frequencies, so you've got frequencies of long runs, you've got many sets of trials that are very large with large numbers. Then you can say, okay, so I should take all those frequencies to be what it to be probable that all of those are happening. That the frequency is such and such in such and such range, and then I want to know, okay, how did I get that probability? Is that also a long run frequency interpretation? And I'm worried that there's a regress here. I'm not sure there is, but I'm worried about it. So maybe the answer then is to the question is no. But suppose we mean, I'm going to rewrite Cournot's principle now. Believe act as if the frequencies will be near R in long runs. Then yes, that's more or less a frequentist interpretation. It says believe act as if a frequentist interpretation is true. But it's a different principle because it actually doesn't mention high probability. And for question 3,
Marshall, sorry, you're out of time. But actually, if the following slides are very quick, you can just I can give you 1 more minute if that's possible. Or you can
I'll just skip this slide. So for the game theoretic probability interpretation, so the question is that a frequentist interpretation? And I think it may be like, to me, it seems like it's like a frequentist interpretation if your claim is that reality just behaves the way it does. You're not adding in some assumption that reality is supposed to behave that way, or there's some mechanism that makes it behave that way. Reality is producing the frequencies in effect. So if you just say the frequencies just are whatever reality says they are, then I think it's like a frequentist interpretation. And I'll stop there.
Thanks so much.
Okay.
Next is Robin.
Let's see.
All right, let me see if I could share my slides.
Well, Robin is organizing. Maybe I should mention to Marshall and the other speakers that Snow has a way of embedding or linking to the PDF and the YouTube where the video will be posted. And also, I think Harry can do that on Researchers One. So if you send it to Snow, we can get it linked with the YouTube.
All right. Thank you very much, Glenn Snow, for getting me to comment on this panel. I think this question is very deep, and as a statistician, although I have been hanging around in this philosophy foundations of probably seminar for years, it is nerve-wracking to have to start to offer my own opinions on things that I think, as we probably have seen from Marshall's presentation, that invariably wouldn't really have a definitive answer. And I myself have felt this particular way, but still, here would be my attempt to kind of address or, and provide my viewpoints on the 4 questions that Glenn posed for our panel. The first question is about the repeated sampling principle, and this is something that every statistician perhaps grow up knowing and understanding, and kind of hold dear to our hearts, that this is something that we should always keep in mind when trying to design procedures, be it in the Bernoullian tradition or the Bayesian tradition, that we would have to pay attention to the behavior of the procedure in their long run, and this behavior is specifically pertaining to the hypothetical repetitions of the data generating procedure. And is this a frequentist interpretation probability? I would say yes, definitely. And this is what Alan Hayek would be calling hypothetical frequentism. I guess this line of quote that I had from Glenn's handout is sufficient enough to say that this is a hypothetical frequentism. But my understanding of the Cournot principle perhaps is that it is broader. So this particular section I got from Glenn's earlier working paper. This is your translation of the original Cournot principle in this most succinct form into English, and it says that the physically impossible event is therefore the one that has infinitely small probability, and only this remark gives substance, objective and phenomenal value to the theory of mathematical probability. And here, Cournot is essentially talking about the kind of moral certainty that, as Marshall was saying, and essentially probability, barring probabilities, events with infinitely small probability or sort of negligibly small probabilities, everything else, that is what gives, or that's essentially the bridge that sort of connects the world of probability to the actual world where, as we know it, where we do understand things happen, where they don't happen. Is this a frequent interpretation? I don't think it necessarily has to be, for many reasons, and Marshall has already mentioned that, depending on what do you mean by that, and for someone who has been more or less trained from the Bayesian or the personalist perspective, I think it is nevertheless something you can say as a principle without having to attach frequency meanings to probabilities. But I should add this sort of a note to say that it seems to me nevertheless that this mostly hypothetical frequentist interpretation cannot be we cannot escape that if we want to somehow operationalize Cournot's principle in branches of statistical inference that tries to, in fact, actually make something out of strings of data, and be it Bernoullian, or the otherwise people would call it the frequentist tradition, or in the Bayesian tradition, or in the perhaps the modern fiducial transition, and as well as the game theoretic tradition. I'm gonna talk about more of the Bayesian view, and kind of in part because I think under the Bayesian tradition, probabilities are more personalist, more subjective, and therefore it hits kind of a better contrast with the frequentist interpretation. And also because I think I don't know game theoretic probabilities well enough to really offer a more educated comment on this. But if we think about the practices in Bayesian inference and how Cournot's principle manifests itself in there are these different aspects. I think it's essentially a reflection of the principle. Considering the Bayesian learning, Bayesians care about being able to achieve certainty through experience. So this is, due with strong law of large numbers, considering asymptotic Bayesian certainty. And Jim Savage writes about how the Bayesian learn through experience to the point of being very certain about an outcome. So this is the learning aspect. And essentially, the kind of certainty that we achieve through experience, through learning, is a reflection of the Cournot's principle. There are also two kinds of assessments that Bayesians care about. One is internally, whether we have posited a good model, whether our beliefs about how the world works, our prior specification, whether these things are reasonable. So this concerns Bayesian model checking, prior predictive p-values, posterior predictive p-values, and these are the things that we also teach I teach Bayesian statistics at Rutgers, and this is the kind of things that we tell students that they need to do as a good practice for good model goodness of fit in the Bayesian tradition. There's also this kind of, well, I should add that that kind of assessment differentiates itself from the kind of calibrated Bayesianism, where the latter is asking for that we assess the frequentist properties in the Cox and Hinckley way of Bayesian procedures. If we produce posterior regions, can we then say that the posterior region, in fact, also has the kind of nominal frequentist coverages, and try to strike this balance between Bayesian and frequentist procedures? I think calibrated Bayesianism it concerns external assessment, whereas model checking, a lot of time, goodness of fit is an internal assessment about whether the belief that the modeler holds is reasonable or not. And because the goals are different, I think they also invoke different kinds of hypothetical frequentism that underlie the three. And if we think about Alan Hayek's criticism of hypothetical frequentism, there are essentially two broad classes of problems that Alan raised. One concerns the postulation of the existence of a limit, whether the limit actually is unique, whether it exists, or whether there's only not more than one. There's also this other issue that has to do with invoking this counterfactual sequence of data that we do not get to see. And on those two fronts, I would like to state that my opinion has been that hypothetical frequentism, it may be better justified when used to formulate learning, and also perhaps the internal kind of assessment rather than external assessment. I say this not to say that external assessments are not important. They are in fact extremely important. But the problem here is that I think there's some kind of conceptual hurdle between using hypothetical constructions of the frequentist interpretation as a way to justify as an external validity assessment. And I say so, if we look at the kind of arguments that have been raised in the literature against the three kinds of Bayesian endeavors, learning, internal assessment, external assessment, and let's just take a look at how exactly what goes wrong, or what might have been the objection towards the use of hypothetical frequentism. In the learning situation, there has been this criticism, literature under the name of Bayesian orgulity. Namely, the concern there was to say that if you think about how a Bayesian would be able to achieve moral certainty is through, first and foremost, posing a prior distribution that assigns a measure of 1 on a set of limiting sequences that have a well-defined limit that goes to that particular value that one would, that limit that we wish to learn. And the problem with that is that measure that we assign a prior measure of 1 is nevertheless negligibly small when viewed in a topological point of view, when one takes the product measure as the product topology as a topology. That particular set that has a limiting frequency that's well defined is a set that is meager, meaning that it's a countable union of nowhere dense sets. So it's very small, and therefore the Bayesians are considered immodest by having to a priori assign 100% of our belief over a topologically small set. I have personally been not so sympathetic with this criticism in a way, because it is true that all of these constructions are hypothetical, and I think this would fall under Alan Hayek's criticism to say that why are we how come can we construe such a kind of a well-defined limit and so on. But at the same time, if we really take that kind of stance, then statistical inference wouldn't be possible at all. So there's some room that I guess we just have to give us to be able to enable learning as a whole. I think this orgulity argument really isn't just a criticism on Bayesian approach at all. It is really something that underlies all of learning rules that appeal to law of large numbers. And as a statistician, I find it difficult to let that go, and which is why I think in the learning case, hypothetical frequentist constructions are perhaps okay. Now, with internal assessment, I think the criticism.
Sure, Robin, just to let you know that you're out of time, but yeah, I think you're also finishing.
Oh, yeah, sure, yeah. So I won't say too much about internal assessment, other than to say that I think the arguments against it mostly just to point out that there is in fact this mismatch between that and how the external assessment has been done. For example, the posterior predictive p-values are nevertheless overly conservative, and they don't, when judged against this external kinds of hypothetical sequence. And the issue with external assessment is that whenever we do this kind of assessment, we really do have to imagine how the world really works. And I think this is perhaps a really difficult hurdle to come about, that we invariably will have to misspecify that hypothetical sequence, and we really don't really have a good idea of what that really would be externally, because part of that is what this is trying to learn. So I don't know how to really resolve this. I think this probably is generally true for Bernoullian. And again, with that theoretic probabilities, that we do have to imagine whenever we try to assess our method's performance in the real world, we have to construe this hypothetical sequence, but nevertheless, we don't really know what that is. And it's a thing that, I don't see how to resolve readily. But I'm curious to hear what other panelists have to say.
Thanks so much. So next we have Alistair.
Oh yeah, hello. Thank you, Marshall and Robin. And that's actually an especially good point for me to come in on, because I don't necessarily have all that much to add to this discussion, except for a discussion of what hypothetical frequencies might mean or amount to from a more metaphysical point of view. So that was kind of what I was going to focus on in my remarks. But just to kind of start by kind of putting cards on the table and answering the questions directly. I don't have slides laying out these answers, I'm sorry to say, but hopefully you can kind of track. The general theme is going to be that it kind of depends on the metaphysics of the situation. In particular, it depends on whether you take there to be kind of objective physical probabilities in the world, and how one sees those as fitting in with the frequencies that I actually obtain. So whether the kind of hypothetical, just answer question one, focus on the hypothetical frequencies. I think it depends what you think of the metaphysics of the hypothetical frequencies. So if they, in some sense, happen, albeit remaining hypothetical, but still happening, then this could, in fact, be a kind of a straightforwardly frequentist approach. One way that could be, for example, would be in a metaphysical modal realist picture, where there are multiple possibilities genuinely exist. We're in one of them. The others are real. Then, when one has what we think of from our kind of world-bound point of view as a hypothetical frequency, is from another point of view an objective frequency, like just a straightforward frequency across like multiple possibilities. So translating hypothetical frequencies into existing frequencies by that sort of modal realist maneuver would be one way to understand hypothetical frequencies that would make the hypothetical repetition approach that would make it much closer to a frequentist approach. It's frequentism, but kind of across possible worlds rather than just within our world. Of course, there's many questions to ask there, but that would be one direction to take the hypothetical frequentist approach that would, so this kind of, to ground a hypothetical frequentist approach, put it that way. To answer question two, it wasn't clear to me how Cournot's principle by itself could counter frequentist. I think it would have to be embedded in a larger theoretical framework before you got something frequentist out. And I take it that was kind of in the spirit of Marshall's remarks as well. And in particular, I want to say that, like, if you have a counter probability that can handle objective chance of the kind that maybe physics is telling us about, then it seems like you have to at least recognize the kind of correctness of Cournot's principle. So like just merely taking that principle to be correct can't make your view into a frequentist view. To some extent, perhaps like the suggestion is that taking that to be the whole story about probability in some sense, or a very important part of the story about probability, and you don't need all that much else on top of it, might be closer to making the view frequentist. But by itself, I don't see that Cournot's principle is kind of in any sense the kind of property of the frequentist. From a philosophical point of view, question 3, do these interpretations differ? I mean, yeah, I mean, from what I've said, I see them as quite different. And one thing I'm kind of hoping to understand today is kind of the perspective from which they could seem so close as to be the same, which is coming through from Glenn's handout. On the fourth question, I'm not familiar with game theoretic approach, interested to hear about it. I definitely see how the principle described here expresses something like Cournot's principle in that framework, something like a kind of game theoretic probabilistic implementation of Cournot's principle. But exactly how we kind of understand that principle in that framework, it seems to me, will still depend on some substantial questions about the metaphysics of chance or objective probabilities in that framework. And from what I can imagine, one could have game theoretic approaches that do and don't have kind of underlying objective chances feeding in, perhaps what I would call underlying objective chances feeding in. But to the extent that they do, it seems to me that, like my answer to question 2, it's not something that's necessarily frequentist. It kind of belongs to everybody, that sort of principle. So in short, kind of the kind of theme of these remarks is that the metaphysics of the situation and what the frequencies are frequencies over, kind of how far one extends one's focus with those frequencies can matter. And there's this suggestion I made that one way of extending frequentism to incorporate the repeated sampling principle more directly would be to expand, at least from one perspective, one's kind of the frequencies that one is focusing on to extend across modal space in the way I described. That would bring frequentism and the repeated sampling principle much closer together, it would seem to me. But like a related point is that philosophers of physics have explored at times over the last couple of decades theories, particularly many world theories, which have unusual looking quantities that are said to play the role of objective probabilities, chances. In particular, say in the Everett approach, there are these quantities, branch weights. Everett specifically refused to think of those as probabilities, but modern many worlds approaches often do kind of take an approach where objective probabilities are compatible with a many world approach rather than having to be rejected in light of it. And so then they want to say that those quantities, the branch weights, are kind of play the theoretical role of objective chances. They are objective chances. And so something like Cournot's principle has to be true of those. So you, for example, have a principle that says something like, if imagine a very idealized case, you've got a branching into 2 possibilities. One of them is super highly weighted and the other one is super low weighted. You can effectively assume, take it for granted, that you're going to be on the high weighted one. Why? What is it about that thing, this physical quantity weight, that kind of justifies that assumption? I think that's a kind of open question, but the way I've argued in my work on this is that kind of that's a challenge for everybody. Everybody needs to assume something, some kind of primitive principle of epistemic kind of compulsion to do with whatever one takes to be the physical probabilities out there, if there are any. And I think it's not any harder in the many worlds scenario than it is in the one world scenario to make sense of how some physical quantity could kind of guide rational expectation. The way I'm used to thinking about that is in David Lewis's terms, the principal, which I take it kind of entails Cournot's principle in a kind of straightforward and easy way, but of course is a much more kind of full-blown account of probability, much committed to much more than the frequentist accounts, I guess, of the simple kind would want to be. And it's not clear whether you really can get the full principle from Lewis's best system approach. Of course, that's another talk for another day. So yeah, anyway, summing up, the theme of these remarks is just that whatever explains why Cournot's principle is the right thing to do, if physical probabilities are on the scene, will depend sensitively on what the metaphysics of those physical probabilities are. And there are some scenarios where that actually looks surprisingly frequentist. For example, if you're considering probabilities related to frequencies across different worlds, not just ours. That's hopefully some things to think about. Thank you for the invitation again.
Okay, thanks so much. And last we have Harry.
All right. Just give me oh. Okay, so thanks for the invitation, and thanks to the earlier speakers. Some of the things that were said earlier were things that I had already intended to say, but several things I'll add to what's already been said. I noticed that the focal point of the earlier speakers was on the interpretations of probability, the frequentist interpretation of probability, which, as I look at the questions that Glenn posed, the questions actually do specifically mention frequentist interpretation of probability, but the two principles that were presented, the Cournot's principle and the repeated sampling principle, were presented as principles that have been put forward by frequentist statisticians, or statisticians who call themselves frequentists. So from my point of view, from my understanding, there's actually, there may be some relationship between frequentism as a statistical school of thought and maybe the probabilistic school of thought, but those are not the same thing, I would argue, and a statistical frequentist need not be a frequentist in terms of probability or vice versa. So my focus is actually focusing on the principles as principles of inference, rather than focusing too much on the interpretations of probability, which I think are definitely secondary, or far lower on the priority list from the standpoint of the meaning or the importance of these principles. So here were the questions, quickly summarizing what Glenn asked. Is the repeated sampling principle frequentist? Is Cournot's principle frequentist? Are those two principles philosophically identical? And is the principle underlying game theoretic probability frequentist? And just quickly to have my answers, which I'll discuss more on in the next several minutes. I would say the repeated sampling principle, yes, is frequentist. Cournot's principle is not. The repeated sampling principle and Cournot's principle are not identical philosophically or practically speaking. I noticed that I think in Glenn's description that they are as instructions. I forget the exact wording that was used, but saying that they are, for practical purposes, identical, but I also don't see that connection either. And as far as the game theoretic probability is concerned, I think that there are frequentist components to it. There are non-frequentist components to it, and I'll discuss those towards the end. Although ultimately, I would say that game theoretic probability is not. It certainly doesn't rely on the frequentist interpretation of probability, and I don't think that it's frequentist statistically either necessarily, but I think there's more room for discussion there. So just to highlight, to discuss the two principles in particular, and to discuss them, or to kind of distinguish between them as statistical principles versus probabilistic principles versus logical principles or principles of inference. The repeated sampling principle, as it was given to us says that we should assess statistical procedures by their behavior in a hypothetical repetitions under the same conditions. Cournot's principle is that we should justify inferences by statements to which the model gives high probability. On the repeated sampling principle, here we're talking about we're assessing statistical procedures, and it says that we should consider the performance of the inferences that are drawn over a long series of repeated or similar situations. And that's the sense in which frequency comes into this. And I think that this is as good as any that I've ever heard as a defining principle of frequentist statistics. It doesn't actually require a frequency interpretation of probability. Probability is inherent in statistical inference, but the statistical procedures are going to be drawing inferences over a long series of repetitions, which doesn't necessarily mean the probabilities in those models or in those procedures need to be frequentist in order for the assessment of the statistical procedure to be frequentist. For Cournot's principle, this just strikes me as a principle of common sense or of intuition or of inductive inference, actually, that when we act on our common sense and we interact with the real world and we make inferences, we go about our business assuming that something is true for all practical purposes. And that's coming at it from the perspective of if something is sufficiently probable, and that notion of probability is a concept that we have in our intuition that we can reason with without referring to any mathematical theories of probability or anything of that nature. And so I think that that's actually a distinction that, regardless of whether Cournot, even though Cournot may have been looking at this from the point of view of mathematical probability, the concept of probability and assigning something high probability is something that's that precedes any formalization of the concept. And I think that's something that actually gets lost in most or all that I've come across, all modern philosophical treatments of probability. And of course, this principle on its own, as the other speakers have said, requires no frequency interpretation at all in order to make sense. And so from that point of view, it's not frequentist, although it's certainly compatible with frequentism. So this discussion, I think, does also get to what is the role of probability in inference, and as I mentioned, the repeated sampling principle specifically refers to statistical procedures, not to probability. So the probability only comes in through the fact that the probability calculus is a fundamental part of statistical inference. In Cournot's principle, I think probability, without knowing the historical context, which Glenn provided in his recent paper, but if I were to read that out of context, I would not necessarily think that it has anything to do with any specific interpretation theory of probability or what is now philosophically recognized as probability. It invokes probability more in concept, as I said, the way that we intuitively think of it when we reason about things in our everyday lives. And game theoretic probability comes primarily through the prices or the odds and the relationship to other interpretations of probability, as Marshall mentioned, to me is also not immediately clear. So what does it mean to be a frequentist? This is something that I mentioned earlier. I think that from a statistician's point of view or from a probabilist point of view, these two things mean different things. The probabilistic point of view, I think, is actually pretty straightforward, even though there's been a lot written on it, and the Encyclopedia of Philosophy's entry is might be very long on it, but it's from a conceptual point of view, we just regard probabilities as frequencies, and we can make that more complicated if we really want. But the statistical point of view, I think the definition of frequentism is actually much less clear. But I think that these principles, the principle that was stated, the repeated sampling principle, actually provides a relatively clear understanding of what it might mean. I won't dwell on this, but I actually was struck when I was presented with these questions, and maybe this just highlights my position here as a statistician, or someone who's more concerned with the practical aspects of things than as a philosopher, which is I was curious as to why the questions in the panel were even being asked. Why should we even care whether something is frequentist? Certainly, it's fine to interpret, to work with frequencies, but there's a whole lot of other ways that we draw inferences, and ultimately whether a principle of inference is valid or useful ultimately comes down to whether or not it makes sense, not whether or not we give its objects a particular interpretation, frequentist or otherwise. I think I have about a minute left here, and I do want to just conclude by talking about game theoretic probability. Glenn gives this definition of game theoretic probability, or this description of game theoretic probability, that the betting or game theoretic version of Cournot's principle can be stated this way: a system of probabilities, or more generally, a system of betting offers, or a forecaster whose forecasts are interpreted as prices, predicts an event if there is a strategy for betting at the offered odds that multiplies the capital at risk by a large factor unless A happens. As I say this, I'm not sure if this is, I'm not sure also there's been discussion of game theoretic probability, also game theoretic statistics, and whether and the extent to which those two are interchangeable or not. But the final slide here is just to discuss, in my view, or in my interpretation, what the frequentist and non-frequentist elements of game theoretic probability are. And the frequentist elements, in practice, a betting strategy will multiply capital only if its assessment of the outcome is closer to reality, in the sense that the bettor, the person betting, or the skeptic in Glenn's framework, is better at what they're doing than the forecaster is at what they're doing over a sufficiently long series of trials. But this doesn't require that the probabilities themselves are frequencies. But there is a little bit of a repeated sampling principle here, in the sense that forecaster and skeptic are repeatedly playing a certain game that have certain rules, although they're not betting necessarily on the same events over this period of time. The non-frequentist component is that I would ask, well, where do the offered odds or prices come from? In the game, they come from the forecaster, but in reality, where do they come from, or what's the connection there from a practical point of view? And noting that the probabilities or strategies also are predicting an event relative to the offered odds or prices, and that the probabilities need not actually represent accurate frequencies in order to multiply capital. The only thing that the skeptic needs to be is better than the forecaster in order to multiply capital. It doesn't mean that they have to actually have accurate frequencies, as far as I understand it. So from this point of view, I would say that game theoretic probability is not frequentist. All right, thank you.
Okay, thanks so much. So I see that Glenn has a hand, and also Barry asked a question about Cournot's principle and the principle in the chat. So perhaps, I don't know, which one of you would like to go first? Also, Barry, I think the question might also be addressed in next week's meeting, or if not, the week after. But it's definitely related now. So
I didn't hear you, Snow. Did you say my question will be addressed or has been addressed?
Will be addressed, I think.
Good.
Glenn probably knows better whether or not.
Well, I've asked Glenn these questions before, but I've never been clear about them. I thought a bunch of people are here, maybe I find out what people think. And Alistair did say something relevant to this in his talk.
Yeah, how about you do first, and then Glenn, you can ask your question later. Yeah, and then also Philip. Thank you.
Like, go first, you mean me? So,
yes.
Right? Okay.
Yeah.
So I've been puzzled about when I first heard about Cournot's principle. Let me say this right off, although it'll annoy Glenn. I see he's getting annoyed already. And that is that I was struck by Cournot's principle sounding to me, so I called it, it's a poor man's principle. Because that's how it seemed to me. It seemed like it was making a connection between objective probability and something like belief or confidence, and which the principle does, but in a graded way. But I know that Glenn doesn't think about it like that, though I don't really understand exactly what the issue is here. I saw that Alistair seemed to think similarly to what I was saying, that Cournot's principle says in an extreme way what the principle is saying. The trouble with Cournot's principle is that the way it says it, it brings to mind any philosopher. Immediately, a philosopher is going to think lottery paradox as soon as they see the usual statements of Cournot's principle. Now, it's possible to fix it up, as Glenn and other people do, so that you avoid the lottery paradox. But I do wonder whether it's really the case that Cournot's principle is the only way, as some people say, of making a connection between objective probability and making probability objective, so that you have objective beliefs about probability, or whether the principle is another way, and whether the principle is just a more general way. So I'd be curious what people think about this.
Marshall, is this on this question? Yeah, come on. Right.
Yeah, just a quick comment. To me, it seems like Cournot's principle. So it's not exactly a poor person's principle. It's a poor person's principle with rounding, right? Because if the probability is high, then you're supposed to believe it fully, at least under one interpretation of Cournot's principle. So it's a little bit different, I think, from what Barry and Alistair said. I think that's all.
In that case, it actually contradicts the principle.
Yeah, strictly speaking, it does.
Yeah, that's what I was saying. So that's what I wanted to get cleared up about.
Aditya, is this also on this question?
No, it's a separate comment. So
okay, I'll put it down on the list. Yeah, thank you.
I've got my hand up. Can I talk?
Of course, yeah.
I want to talk about the repeated sampling principle. What you think about it is complete nonsense. It says assess a procedure on the basis of its performance in hypothetical repetitions. How can I do that? I mean, it's completely impossible. I don't get to see these repetitions, so how can I possibly assess anything on that basis? So on that, and if you think about it, it's completely unnecessary for frequentist statistics. There's nothing frequentist necessarily about so-called frequentist statistics. Let's go to a Fischer hypothesis test. You test a hypothesis. What does Fischer say? Either the hypothesis is true or an event of small probability has happened. If we don't want to believe that events of small probability happen, then we must reject the hypothesis. Now, it says nothing about this event of small probability must be interpreted in terms of repetitions of the whole experiment. It can be, I can have any interpretation of probability I want, although I probably should have some adherence to something like Cournot's principle in thinking that small probabilities mean I don't think something's going to happen. But the whole so-called story of frequentist statistics is an approach which is based on probabilities, which are always single case probabilities. If you do build a statistical model, you're attaching probabilities to specific events, not repeated events, unless you happen to be thinking of a sequence as part of your model. How you choose to interpret that probability is up to you. And although it's traditionally almost universally interpreted in this ridiculous expression, assess it in terms of its performance in hypothetical repetitions, not only is that impossible, but it's not necessary. Just interpret a probability as a probability, even a subjective probability. So there's nothing frequentist about frequentist statistics.
Anyone from the panel would like to respond? Or Glenn or anyone else?
Well, yeah, maybe I should respond. I think in a way, Phil is saying the same thing as Harry did, is that frequentist statistics is not talking about a frequency interpretation. Although somehow I wish that we had more common ground between the philosophers and the statisticians, so that when the philosophers discuss frequentism, they look at what the statisticians are thinking or saying. But I guess I would ask both Phil and Harry, this talk about the hypothetical repetitions, isn't it just a sort of a way of dressing up a appeal to Cournot's principle that says, well, when you're assessing in terms of hypothetical repetitions, you're saying that this will almost always work, and it not working has a small probability. I mean, the hypothetical repetitions are just an appeal to some kind of law of large numbers. If you were to repeat the whole experiment over and over, which you aren't going to do, that's the hypothetical repetition, then you get what you want with a very high probability. So is it the repeated sampling? I guess I'm addressing that to Phil and to Harry. Is it the repeated sampling principle a fancy way of appealing to Cournot's principle?
Yeah, I think it probably is, because for those people who can't understand probability except in terms of repetitions, but for those who have rather more sophisticated interpretations of probability, it's not necessary to do it that way. I think what happens is that most statisticians have been, when their introduction to probability is frequentist, and therefore they don't understand what a probability can be, except something which reveals itself as a frequency in repeated trials. But there's no reason that it needs to be interpreted that way. It's just that these people have no way of interpreting any other way.
Glenn, I would say maybe there's more to these principles than the one sentence description that's given. But the repeated sampling principle says assess a statistical procedure based on how it will perform in hypothetical repeated trials. It doesn't say. It actually doesn't say how to assess it. It just says that use that to be the use that as the basis for your assessment. Whereas Cournot's principle is explicit in terms of, if you give something a high probability, then act as if it's true, or proceed with, for all practical purposes, as if it's true. So I actually, off the bat, see them as not saying the same thing at all. Although I would agree that frequentist statistics is the way that it's often practiced is consistent with Cournot's principle, but that only makes Cournot's principle a more general principle, or a more general statement than the repeated sampling principle.
Well, the repeated sampling principle is, when it's used, isn't it always saying that with a high probability, this method will give you the right answer in repeated trials? With a high probability, this will happen 95% of the time. Isn't there a, how do you get that with a high probability, and if imaginary repeated trials, infinite trials, this would happen 95% of the time? Well, only it happens 95% of the time with high probability. There's no, there's an implicit appeal to Bernoulli's theorem, and further translating, cutting off the, that there would be enough repeated trials so that probably be very small that your statement's not true. So I've always taken this repeated sampling principle as Phil, I think, was agreeing, as a way of hiding Cournot's principle, if you will, because that sounds silly to people or something.
Can I get back to Fischer's null hypothesis, which I think is basic but quite instructive? As I said, I think that your 5% or Fischer's 5% is not necessarily to be construed in repeated terms. But I think it also sheds a different light on Cournot's principle, which is one I prefer, and I think I'd like to have Glenn's view on this too. It doesn't tell you what to believe. It doesn't tell you how to act. It tells you what a hypothetical model, which involves probabilities, is asserting. So that model may be my brain, or it may be a statistical model I'm thinking might or might not describe aspects of the world. And it says that if I can identify an event which this model assigns very, very high probability to, then that model is essentially asserting that that event will happen. It doesn't mean the event will happen. It doesn't mean I have to believe the event will happen. It doesn't mean I have to act as if the event will happen. It means the model is saying that. It's almost, it's as far as close as I can get to deterministic output of the model. I can then, as in a Fischer null hypothesis test, see, is the model saying something sensible? It's saying this, does it happen? Cournot's principle could be used to test the model. If, and this is very much in the spirit of game theoretic probability. It says that if an event the model assigns very small probability to happens, or if I make an awful lot of money betting against the probabilities in a model, then I should think there's something fishy about the model.
I couldn't agree with Phil more. I wanted to bring up, I know Marshall has his hand up and Aditya, but I just wanted to dip in, and Robin, but I want to dip into the conversation, the example of the gambler's ruin, the theorem of gambler's ruin proved by Ampere in 1803, which says that if you keep gambling, eventually you'll be ruined. The probability approaches 1. That you'll be ruined if you keep making unit bets over and over, and you find somebody to bet against. That was what he proved in 1802. The probability 1, if you go on forever, it's probability 1. As you keep going, it approaches 1. So you're going to be ruined. That's what probability says, Ampere said. So I think that has to be interpreted the way Phil's talking about. I agree.
Actually, on that point, before we go on to the queue, I just want to make sure that we also come back to Barry's question initially, because we sort of cut it off. Since this is also on this question about Cournot's principle and principle. It seems like now, Glenn, you're also thinking that Cournot's principle is not the same as the principle, or doesn't entail the principle. And it might even contradict principle.
Yes, I agree with Phil. It doesn't say what you should believe. It says what the model is saying, which is what if you go back and reread that quote from Cournot that we've seen on the slides a couple of times, he says this is the only way that the model, and I think that's what he's saying, that mathematical probability, not mathematical probability. It's the only way mathematical probability makes contact with phenomena. And I think Phil had a way of saying that. It's the only way the model connects with the world, says what the world is going to be doing. So it's what the model says, not what I believe. I think that's right. So maybe that is a better answer to, Barry and I have been discussing this forever, and I think maybe Phil has addressed it better than I've been able to in my conversations with Barry. Thank you.
Can I say something more about Cournot's principle, which even if you try and relate it to frequentism by thinking about what happens in or even real repetitions, maybe better than hypothetical repetitions of an experiment, there's actually no need to restrict it to such a simple way of thinking about things. For example, you can apply it to stochastic processes, you can apply it to spatial models. Any one of these models, there will be, as long as there's an essentially infinitary scope, that it can consider lots and lots and lots of different things, there will be non-trivial events which are probably of meager events, one might say, events which aren't logically bound to happen, for which your model will assign probability as close to 1 as you wish. It doesn't have to be anything to do with frequencies. It could be a calibration event, for example, in completely arbitrary probability sequences. And the model is saying, I expect this to happen. And you can test, does it happen or not? And therefore you can test the model. Forget about frequencies. There are other things you can use to test the model with Cournot's principle.
Well, Phil is my choir here. I agree entirely with him, and it's a point I'd like I wish we could. I wish Alan Hayek had made it the conversation, because it's a point I would like him to absorb, and maybe Alistair and Marshall also, that we're not just talking about a frequency approximating a probability. We're talking about maybe the frequency is approximating an average of probabilities, like in a stochastic process, or Phil is alluding to much more complicated stories. So that seems to go beyond any identification of probability with frequency. Although, you know, as I was trying to persuade Harry, this kind of repeated sampling principle is kind of a trick where you can take any event of small probability and sort of say, oh, we're going to repeat the whole model over and over and over, and that event of small probability will not be happening very much. And so we translate the application of Cournot's principle into something that sounds like repeated sampling. I don't know if that makes sense to Phil, but I'll sign off here and let the other people address their questions.
Okay, we have sort of a two here. So actually, because Phil's comment also relates to what Robin was presenting. So I was just wondering whether or not, Robin, you want to quickly jump in? And also you made a comment in the chat. Hi, Robin.
I just wanted to, my comment was inspired by, you know, our discussion about, you know, potentially, in fact, understanding some of the, I have been calling in my comment Bernoullian, which is following what Glenn's proposal of just calling frequentist statistics as Bernoullian statistics instead. But in my view that, just thinking about when people propose a statistical methodology and they publish a paper to talk about it and to say that this thing has, you know, good properties, they appeal to justifications that there is really a class of hypothetical sequences that people imagine, and against those we say that certain procedures perform according to certain standards. So whether or not the probabilities that are put forth could be understood as a frequentist or subjective or personalist or otherwise, I think, you know, just by construction, a lot of these things do give rise to a frequentist interpretation, whether we like it or not. So I typed in a comment to say that the Fischer's exact test, as I understood it, you know, when we test for whether the causal effect of is the Fischer's sharp null, what we do is that we imagine the sharp null being true, and then we go in and then draw from the distribution of the two branches of the manipulation, and then we tabulate, and then we look at whether the observed difference, in fact, you know, it lies far in the tail and stuff. So that tabulation of the reference distribution to me is the construction of the or an instantiation of the first many observations of a hypothetical sequence. But I think, Phil, you might disagree with that.
Well, I've put my disagreement in the chat. Yes, I mean, the model tells you how to compute the probability. That's all you need. You don't have to think about the sequence of anything in order to understand this is what the model is saying, or the null hypothesis is saying. It says that the probability of being further out in the tail, if you like, is 5% or less. It's up to you how you interpret that probability. I would interpret it as meaning I don't think it's very likely. You don't have to interpret it as meaning I've got to do the thing over and over and over again.
I don't disagree with you on that, but I think the construction of the whole practice hinges on looking at the hypothetical sequence that was constructed under the assumption that the null model is true. Whether how we interpret the output as the inference, I think that's a different thing. And it means different things to different people.
I think we're going to have to agree to disagree on that one, Robin.
Let's come back to this point later. So first, Aditya, thank you so much for being so patient. You have your hands up for a long time.
No problem at all. It was very interesting to listen to this discussion, so I don't mind waiting. I wanted to give a bit of a perspective of what, let's say, I'm unfortunately representing a few young statisticians here along with Harry, but I do think that I agree with him that frequentist statistics and frequentist probability are somewhat disconnected. And apart from the use of the word frequentist, I don't think that the practice of frequentist statistics depends on the interpretation of a probability in the frequentist sense. And I think that typically these days, young statisticians who think of themselves as frequentists have some few things in common. One is they are not Bayesian. They don't think of probabilities in a Bayesian sense and don't like putting their own priors and things. So they're non-Bayesians. They think possibly that the possibility of there being some kind of an objective reality, and usually they'll work with some kind of probability calculus like the Lebesgue calculus or Kolmogorov's axioms. They don't think too philosophically about where the right calculus should I countable additivity versus sub-additivity, and they're like, look, give me a calculus to work with. I don't think that probabilities are subjective, and then they act on that. And I'm not saying that this is the way things should be. I'm saying that this is the way things typically are. But if you forced them to answer the question of what a confidence interval is or what p-values are or so on, they would come up with something like the repeated sampling principle. Like if science publishes a lot of different 95% confidence intervals, then 95% of those intervals will cover their parameters and things of that kind. And like they don't think of it instance by instance. They think of it often in some kind of an aggregate sense. But I don't think that necessarily means that they think of all of probability in terms of these kinds of limiting frequency things. Like sometimes they just think of probability in terms of a probability calculus to reason with uncertainty. Now, unfortunately, there's been this disconnect now between the practice of this frequentist statistics and all of this philosophy of Cournot principle and repeated sampling principle and like von Mises and all of these things. I don't know if that's good or not, and perhaps it would be interesting to hear the comments of the panel of whether this is a good thing or not, or whether we need to bring back the philosophy into the statistics, or whether the philosophy and probability can have their own conversation, and meanwhile frequentist statistics can go on not really bothering about which of these principles everyone is thinking of in the foundation. So because they don't, the reality is they don't, and the question is, do they need to? And my argument is, I don't think they need to. They can work with whatever interpretation of probability they're comfortable with. And I don't think they actually need to believe in any one of them. And I think the same thing holds for game theoretic probability and game theoretic statistics. I mean, I don't know if Glenn agrees or not, but for me, the game theoretic statistics somehow could have been built on measure theoretic probability. In fact, many of us who write about it write on measure theoretic probability. And the reason we do that is because there's something that links measure theoretic probability to game theoretic probability, which is Wheel's theorem, which says, well, any event of measure zero, there's a martingale that can increase to infinity if that event occurs. Okay, so there's some relationship between the two, which now means that we can base it on either game theoretic statistics doesn't have to be attached to one interpretation of probability. That's how I feel. Maybe people here feel differently, and I would like to know what they feel.
Thank you so much. Any philosopher, perhaps in particular, on the panel, or anyone in the audience would like to respond? Yeah, Marsha.
Yeah, I think so. I think often this is true in the sciences often, and I think it's true in statistics that you can do a lot. You can get a lot of work done and be very productive and learn things about the world without answering all the questions about the underlying assumptions that are needed fundamentally to make sense of what you're doing. So I think I want to disagree with Aditya with the idea that there's no relationship between philosophical questions about probability and frequentist statistics, but I agree completely that you don't need to settle that to do most of what you're doing in frequentist statistics. And I don't think, so there's this debate between, like Robin and Philip about whether you have to do repeated sampling in order for it to count as frequentist statistics. But supposing you did, the fact that the procedure and the practice makes essential use of repeated sampling, to me, that doesn't mean it's using a frequentist interpretation of probability. So in that sense, I'm agreeing with Aditya. And I think this is just a matter of subtleties of language. So I actually agree with most of what Robin and Harry and Philip said. I don't think there's a disconnect there. I think there's just this, we're all using this word frequentist, but to me, frequentist interpretation of probability is not central to frequentist statistics, even though, lots of people like Fischer and so on talked about frequency interpretations of probability. And I can pull out a textbook right now that says this is what probability is. But I don't actually think that makes sense. I think Philip's right that many frequentist statistical calculations assume you've got single case probabilities. But let me just add one more thing, which is that, so Philip criticized, said that Hinckley and Cox's phrase hypothetical repetitions, that like it's nonsense to assess procedures by hypothetical repetitions. And I'm very sympathetic to that, but I'm trying to sort of make sense of what they said. And there is this view that the reason that we're licensed to make inferences in particular applications of statistical methods, the reason we're should act as if Cournot's principle is true, is that, well, we'll be wrong. Let's say, maybe we'll be wrong 5% of the time because we've got that's how we're setting our confidence interval or whatever it is, or our p-values. But we'll be right most of the time. So just act like you're right all the time. But the idea is that, so I'm taking hypothetical in the Cox and Hinckley statement to mean this is a good practice. If you do it over and over again, you're going to come out, you're going to get the right answer, most of the time. So just act that way. That's all.
Thank you. Since we're almost running out of time, let's just try to squeeze in both Alistair and also Barry's question. So Alistair, do you want to?
Thanks. Yeah, I mean, my thought follows fairly closely on from that, but let me first just kind of say something quite kind of broader before I forget about the frequentism in the sense of inference methods versus frequentism in the sense of interpretation of probability, because I think kind of there's kind of clearly some relation, but we haven't really clearly pinned down what it is. I guess I just want to kind of put on the table the way I've been thinking about this, which is something like the frequentist methods provided a certain kind of inspiration for frequentist interpretation of the probabilities. So kind of the way I see it, the kind of frequentist interpretation of probabilities takes the repeated sampling principle that I think does play a role in these frequentist statistical methods and kind of runs with it an interpretation of probability. So I kind of see the interpretation of probability as kind of inspired by the methods. On the Cournot's principle point, I think I'm kind of echoing Marshall. The way I would think about the role of it, at least one line of thought that might be what's going on in some people's minds here, is that kind of to act on anything, you need to kind of take it on as a kind of commitment. So there's a certain sense in which kind of, at least for an action to be rational, there's a line of thought that says, well, you need to kind of put this needs to be something you're acting on a full belief, or it's not rational. Ideally, the belief will be a knowledgeable belief, and that sort of line of thought that links kind of belief and action works with full belief, and somehow we need to get from probabilities to full belief. And one line of thought is you can't act on like 95% probability. You can only act on full belief. There's no such thing as acting on probabilities. One only acts on beliefs, because we are belief, desire, psychology. This is not, I'm not defending this, I'm just sketching it. And if you had that line of thought, you might think you need Cournot's principle because you need to kind of turn your high probabilities in full beliefs before they're the right sort of things to act on. I think that's maybe why philosophers might want to kind of give it that centrality. Anyway, I said enough now. Now I want to give Barry some space. Thanks.
Thanks, Barry. Yeah.
Yeah, hi. So there's some talking past each other, I think, because philosophers and statisticians are interested in somewhat different questions. So statisticians are interested in finding out what the probabilities are, what their values are, and methods of finding out what their values are. But philosophers are interested in finding out what probabilities are. And that's a really different question. That's, for example, why hypothetical frequentism comes in. That's a proposal for how to understand what probabilities are. It's maybe a bad idea. I don't agree with it myself, but it's a proposal, as is propensity theories and best systems accounts and so on. Statisticians can go about doing their work independently of what these different accounts are until they get into trouble sometimes. And then they have to look at the philosophers to give an account of what it is that they're talking about. And that has happened in the history of statistics too. So that was one thing I wanted to say, and I'm sure we'll have further occasion to talk about Cournot's principle here. So I don't think we should continue that now.
If I could just, can I say one thing real quick, which is in response to Barry's, so this is where, after I guess being in the seminar now for many years, the what's I find confounding about philosophers is among many things, I guess, but the concern or the interest in what probabilities are instead of the interest in what probability is. I think there's actually a difference there, because the philosophers are very focused on what the probabilities, how the probabilities seem to be instantiated in a theory, as opposed to the concept of probability as it kind of arises in, I guess in logic or in reasoning, more generally speaking. And I think that in doing so, I think loses a lot of the loses in some ways loses the point of a lot of this, because the probabilities are just the way, if they're just instantiated in a theory, if you put them in a theory, they are frequencies, or they are whatever the theory says they are, as opposed to what probability actually is from a epistemic point of view. So maybe you can help me. Maybe you can, or maybe you can, or maybe you don't want to help me understand that distinction better, or how philosophy.
Sure, there's nothing I'd like more. I mean, the idea that philosophers confound other people makes philosophers feel really good. That's what we get paid for. But sure, take for example statistical mechanics, which is a central important theory in physics in which probability occurs. A question arises is when someone in statistical mechanics is making a claim about what the probability of an ice cube melting in a certain amount of time in a glass of warm water, what is it that makes that claim true? So the philosopher is interested in what is it about the world that makes that probability claim true? Not what is it that would give us reason to believe the claim is true, but what is it about the world that makes it true? Does that make sense, Harry?
Okay, I can, yeah, I understand the difference there.
Okay, so that's the question. And it strikes me that a lot of the discussion is talking past each other, because there are frequentist methods for finding out what the values of probabilities are. That's important and very interesting. Okay, but there are also frequency accounts about what probability is. And that's a different thing. They'll be related to each other for sure, but they're different issues.
I guess it seems to me also, and I won't belabor this because I would have to get my thoughts straight anyway, but it seems to me that there is use confounding in a different way. a confounding of the word probability with many different things, right? Because probability, there are people who take a probability interpretation or a frequentist interpretation of probability in certain contexts. That doesn't mean that probability is frequency. It's that
Sure.
frequency might be the relevant component of probability, or might be the relevant concept to work with in a given context, or something like that.
That might be the way we find out about the value of probabilities, by finding out frequencies. If that's what you mean, yeah, totally agree with that. As Marshall pointed out at the very beginning of his talk, there are lots of different quantities that satisfy the axioms of probability. And the notion of probability occurs in many different scientific theories and elsewhere. They may not mean the same thing in these different contexts, but we would like to, philosophers want to know, are there some uses in which we can say, yes, they're the same notion of probability involved? Is it the same notion involved in statistical mechanics as in quantum mechanics, for example? That's an issue that a philosopher of physics would be interested in. And if it is, what is it? What makes it, what is it about the world that makes a probability claim in quantum mechanics or in statistical mechanics true?
I think Glenn
Okay.
wanted to say something.
Yeah, Glenn, do you want to say anything?
Oh, I just want to comment that it seems to me that Barry is describing the way realist philosophers today think, but to say all philosophers looked at it that way seems strong.
Plato. Plato is my model here, actually.
Mhm. Okay, but not all philosophers.
No, not all philosophers.
Okay. Well, I guess we will continue this discussion.
Let me thank everyone also. I know Snow is going to do that, but I organized the panel. I want to thank the guys that and gals that have come and participated, and thank Snow for moderating. It's been great.
Thanks.
Thank you.
Thanks, everyone,
Yeah,
and
it's
thanks, Glenn,
interesting.
for
Thanks. It's good to see you all.
Okay, we'll see everyone next Monday.
Bye.